Okay, we want to find the range of values of x for which this curve is decreasing. Now, it's giving you the curve for x values bigger than 0. So what we're saying is that this curve only exists for x values bigger than 0. So it doesn't exist for any negative x values or indeed 0 itself. So that's important to note at the beginning. So the curve is decreasing when the first derivative is less than 0. So the first thing we're going to do is get the general gradient. And in this case we're going to call it f dashed x instead of dy by dx because we're given f of x instead of y. So let's differentiate f dashed x then. So we're going to multiply this term here by its power, so that's going to give us, what, 10 over 10 x, so we're just going to end up with x, and then subtract 1 from the power, so 2.5 minus 1 is 1.5, so that's going to be 3 over 2, and then differentiate here, we're going to get minus 8. Okay, so we want to get now where the curve is decreasing, so curve is decreasing when we set first derivative f dashed x less than 0. So we're going to set x to the power 3 over 2 minus 8 is less than 0. So we have an inequality. But again, the problem here is that it's not a quadratic inequality, highest power isn't 2, and it's also not a linear inequality. So when it's not linear or quadratic, what we're going to have to do instead is we're going to have to ignore the inequality sign. We're going to solve the equation to get the critical values for this inequality, and then we're going to investigate the sign, S-I-G-N, of the non-zero side of the inequality for all the range of values of x around the critical values. So it's not a quadratic or a linear inequality. So instead we have to investigate the sign of the non-zero side before, between, and after the critical values. Okay, so let's ignore the inequality sign and just solve it as an equation to get the critical values. So we now have x to the power 3 over 2, subtract 8 is equal to 0. So we're going to then move minus 8 over. We'll get x to the power 3 over 2 equals 8. We're now solving an index equation where the base is unknown. So what we do is we take the reciprocal power of the other side in order to make the power of x 1. So we're going to get x equals, and then we're going to have in brackets 8 to the power of 2/3. Take the reciprocal power of the other side in order to make the power of x 1. So that's going to give us the cube root of 8 all squared. You can put the power 2 under the root or outside it. So the cube root of 8 is just 2. Then we're squaring 2, so we're going to get 4. Okay, so there only is one critical value here for x. So we're now going to investigate the sign of the non-zero side for values of x around the critical value. So again, we're going to draw our table. So top row are the x values, bottom row is going to be the sign of the non-zero side of the inequality, which is, if we go back up here, x to the power 3 over 2 minus 8. Okay, so there's only one critical value, so we're going to investigate the range of x values before the critical value. So we're going to look at x values which are less than 4. And then we're going to look at x values which are bigger than 4. Okay, so for example, let's take an x value of 3, that's just immediately before 4, or, well, to be honest, you could take any x value before 4. Let's even make it easier. Let's take x as 1, it's less than 4. So 1 to the power 3 over 2 is just going to be 1. 1 to the power of anything is 1. Subtract 8 is going to give us minus 7. So clearly the sign of the non-zero side of the inequality is negative when we sub an x value in less than the critical value. Let's now sub an x value in which is bigger than the critical value. So let's chuck in, say, x is equal to 5. So we're going to have 5 to the power 3 over 2. So we could go to our calculator. So 5 to the power of 3 over 2. And then we're subtracting 8. So that's going to give us about 3 point something, 3.180. So that's clearly positive. Now, what we're saying here is that x to the power 3 over 2 minus 8 is negative when x is less than 4. And x to the power 3 over 2 minus 8 is positive when x is bigger than 4. So if we go back here, we want to find the range of values of x for which the non-zero side of our inequality is less than 0. So we go to our table. Where is the non-zero side less than 0? In other words, negative. Well, it's clearly negative or less than 0 for x values less than 4. So we have x to the power of 3 over 2 minus 8 is less than 0 for x values less than 4. But do you remember in the question, the original curve only exists for x values bigger than 0. So the inequality is only less than 0 when x takes any value less than 4, but x also has to be bigger than 0. So our final answer is 0 must be less than x, which must be less than 4. So x can take any value less than 4, but remember, x has to be bigger than 0. So the range of values of x for which this inequality holds is x takes any value between 0 and 4.